Hi, so here we are in the fourth section of our course, which is to load and update data in Spanner. Before moving on to the discussion of loading data in Spanner databases, we need to have understanding of some of the important concepts, and that are reads and transactions. So what are reads? If you need to make a single read call, single being the keyword here, or read data in parallel, that are simply the reads. There are two types of reads based on how current the data is: strong read and stale read. Strong read is a read at a current timestamp which ensures that all the data committed up to current timestamp will be seen. By default, reads of spanners are strong reads. Whenever possible, strong reads should be used as they ensure impact of all transactions up to a certain timestamp and hence make the applications more trustworthy. Stale reads read data at a timestamp in the past. This is especially useful when your application can tolerate stale data but doesn't want high latency. In that case, high performance will be achieved. 15 seconds is a reasonable value of staleness to be used for good performance. However, an important point to note is that stale reads won't provide any latency benefits in regional configurations. So always prefer strong reads if the configuration isn't a multi-regional one. Now, coming on to the single read methods. Cloud Spanner supports single read methods on a database for the following cases. When you execute a read as a SQL query statement or use Cloud Spanner's read API, when you perform a strong or stale read from a single row or multiple rows in a table, or reading from a single row or multiple rows in a secondary index. Now, what are parallel reads? When you're reading large amount of data from Cloud Spanner database, it is at times helpful to divide the query into smaller pieces or partitions and use multiple machines to fetch the partitions in parallel. Bash queries are run to execute such reads. Now that we've seen single reads, let's move on to the concept of transactions. Like any real-world example of a transaction, in Cloud Spanner 2, transaction is a set of reads and writes that are executed atomically at a single logical point in time across the database. Supported transaction modes are the locking read-write transaction, read-only transaction, and partitioned DML transaction. Let's have a look at locking read-write transaction. This is the only transaction type that supports writing data into Cloud Spanner. So any writes into the DB are executed as part of the read-write transaction. These transactions rely on pessimistic locking and, if necessary, two-phase commits. So let's move on to some of the properties of read-write transaction. A read-write transaction provides ACID properties of relational DBs, that is, atomicity, consistency, isolation, and durability. Thus, the application developer won't need to concern himself if many transactions are being executed at the same time, as ACID properties in Spanner are guaranteed. Now, the locking mechanism. Multiple clients can be interacting with the same DB at a given time. To ensure consistency of multiple concurrent transactions, Spanner uses a combo of shared locks and exclusive locks to control access to data. When you perform a read as part of a transaction, Cloud Spanner requires shared read locks, which allows other reads to still access the data until your transaction is ready to commit. When your transaction is committing and writes are being applied, the transaction attempts to upgrade to an exclusive lock. It blocks new shared read locks on the data, waits for existing shared read locks to clear, then places an exclusive lock for exclusive access to the data. Let's move on to the read-only transaction. If multiple read calls are to be made that require a consistent view of the data, it involves a read-only transaction. These transactions do not need to be committed and do not hold locks and block other transactions. Hence, they can be executed at any replica. Use a read-only transaction when you need to execute more than one read at the same timestamp. Then there are partitioned DML transactions. A partitioned DML transaction is designed for bulk updates and deletes. For example, periodic cleanups. Using partitioned DML, you can execute large-scale update and delete statements without running into transaction limits or locking an entire table. Cloud Spanner partitions the key space and executes the DML statements on each partition in a separate read-write transaction. As for the properties of partitioned DML, you can execute only one partitioned DML statement at a time, whether you're using a client library method or the gcloud command line tool. Partition transactions do not support commit or rollback, so Cloud Spanner executes and applies the DML statement immediately.